Students, chalenge into the discussion of the different types of coding schemes that we have in our data communication systems. Students, there are two broad categories that we divide our coding schemes into. The first category is called the block coding schemes or the block coding, and the second one is called convolution coding. Students, the convolution coding is not that we used very often in our data communication applications these days, and we are not going to talk about convolution coding, but we will explore what block coding is. Block coding and its different types are basically what we most frequently use in today's data communication systems. Students, in the case of block coding, what we do is, the first step is we divide our message that we need to send into blocks of k bits each. So it doesn't matter how long the message is. We choose a certain number, k, and we divide our message into blocks of k bits each. We'll talk about where did this k come from and how do we choose it in the discussion of encoding techniques. But for now, you need to know we have to take our message and we have to divide it into blocks of k bits each. So in second step, we add some redundant bits shown by R in this particular case. So we add R redundant bits to this particular block to get a code word. So our data word, first of all, our data word is given by a block of k bits. That is our original data word that we need to send. We add some redundant bits given by R, and we get a code word which consists of n bits, where n is equal to k plus R. So k is the original size of our block, or the number of bits that we have in our original data word, and R is the number of redundant bits that we have added. And the resulting block of message, which consists of n bits, where n is equal to k plus R, that is called a code word. And that is the code word that we actually send across the line, and then the receiver receives that code word and it checks on the integrity of this code word in terms of whether it was impacted by the noise and it's got some corruption in there, or it is clean. Students, block coding in error detection works if the following two conditions are met. In other words, the receiver can actually detect the error if the following two conditions are met. Given that we are sending a code word, if the receiver has got a list of all the code words, all the valid code words that are available, and number two, if the original code word has changed to an invalid one. If those conditions are true, then receiver will be able to detect an error. Students, in this particular case, as I told you, the original concept of redundancy that we have discussed, we are actually adding those redundancy bits in our original data words, and the resulting code word is what the receiver is checking upon to see if it is corrupted or not. Students, slide pe chalenge. As you can see, we have got the block coding example both at the sending end and at the receiving end in this particular case. Students, sender ke case mein, as you can see, it creates a code word out of the data words by using a generator, and that generator is doing nothing but is applying the rules and procedures of encoding. Don't worry about those procedures. We will talk about them at a later stage. But at this point in time, what you need to know is that we have got, the sender has actually divided this particular message into small code words of k bits each. We have got a generator which is doing nothing but adding some redundancy bits, and then you have got n bits. So this is where you add R bits. And your n, as I told you, is ultimately going to be, your code word is going to be your original data word plus your redundant bits. So in this particular case, it's going to be k plus R. So this is the code word that's sent to the receiver. Let's suppose we have got unreliable transmission, so there is some corruption in there. This code word, which is n is equal to k plus R, it goes to a checker. The checker checks it according to the agreed procedure between the receiver and the sender, and we will see what that procedure is. And based on that, if there is an error, it will discard the code word, or it will extract the data word of k bits and it will give it to the receiver. Students, you'll see that there is a major limitation in this particular case, and that limitation I will actually explain that to you using an example. But if the received code word in this case is not valid, as you can see, it's discarded. But if the code word is corrupted during transmission, but this checker, so let's suppose our code word is corrupted, but the checker checks that the received word is matching a valid code word. If this is the status that the checker comes out with, it will still extract that data word and it will give it to the receiver. So in the case of checking, if there is an error that's introduced, but the checker gets the code word which is a valid code word still, then it will still accept it as valid data and will extract the data word and will give it to the receiver. If you are a little bit confused about this concept of this limitation, we will explain to you in the form of an example in the next discussion or the next topic.